Hello everyone, today I'll walk you through the generator calculator of very powerful online tool designed to help you size up generators. I created this calculator mainly to select life safety generators, but you can use it to size up any generator. So first of all, go to this website. I'll put the link in the comments. If you go to that website, you will see the generator load calculator there. Just a quick overview of what's what. Equipment, this is where you put your names, then you've got the different load types. There's a little tooltip to explain what type of motor can be used, and also you can enter non-motor load, for example distribution board that feeds lighting in a firefighting corps. If you are selecting life safety generator, you need to take into account locked rotor amps current, especially for sprinklers. That's where you enter that value. Then you've got start current, full load current, and start time. And then there's an action. You can add equipment or remove equipment. Again, if you are unsure about it, hover over the question mark. You will see the little tooltip. So let me explain how to use this table. Let's just use a real scenario from a project. I'm going to add equipment. I'm going to add few lines. Now I'm going to add few names. When you calculate the sprinkler, you have to take into account the locked rotor current, and the sprinkler could typically be DOL or star delta startup. I came across most of them being star delta. The last one I came across, the locked rotor amps was 199 amp. Startup current was 66 amps and the full load current was 26.5 amps. Going to set this startup time 1, and then what you have to take into account is the startup current. To make this work, this calculator, I'm going to enter this in addition to locked rotor amps. Basically use this column only if you want to add this additional locked rotor amps current. The startup is the same as the FLA and also starting at the same time. Now the firefighting lift, evacuation lift, then I've got lift 2, and then I have smoke extract fans. I've got 6 fans, so 1, 2, 3, 4, 5, 6. Let's add them. I have 2 distribution boards. The distribution boards, let's start from the bottom. I am selecting the load as standard. There is no locked rotor current, so I need to enter 0. The load is minimal. It's feeding lighting only. It's 10.64 amps. I copy the same value because it's the same load. And let's say this load will start at 10 seconds after the generator is available to take the load. Okay, now let's go back to the top. So firefighting lifts are typically VSD, variable speed drive, so I'm going to change that. There is no need to enter locked rotor amps current, although I need to put 0. It's only required for sprinklers. So what's my load? 22.65 amp, a startup current. This is taken from the datasheet from the lift. I'm gonna copy that down, and my full load current is 16.77. Just remember to enter 0 here, otherwise you will get an error where you press calculate because you have not finished your work. Smoke extract fan, again 0, 0 in here, and my startup current is 28.67 amps, so I'm going to copy that. It's the same size smoke fan, and my full load current is 12.68 amp. Last thing I need to do when they start, I'm going to start the lift as 1, second lift 7 seconds, and again 1 second and 7 seconds. Smoke extract, I'm going to assume that the 3 of them start immediately after the generator is available, and then add 7 seconds later. Then the lighting DB life safety starts at 10 seconds after the generator is ready. So there we go, you've entered your details, press calculate, and you have your load calculation. And now we got time, 15 seconds distribution of the load will the highlighted maximum value, which is actually happens to be at T9. And then you looking at the time from 16 seconds to 30 seconds on the bottom table, you got the whole load distribution. Let's change the lift and calculate. See, the load will change. You see that starting with the startup current, it doesn't start slowly as in here and gradually grows because the variable speed drive. I'm going to change it back. You calculate again. You see the load updates, perfect. Now let's create a report. A date, revision, name, whatever, and export as PDF. You can download it to your PC. Happy days. Let's go back. Let me explain a little bit how the startup currents work. In a variable speed drive, the inrush is about 1.2 to 1.5 times the normal running current. When it starts, the acceleration takes about 1 to 5 seconds, and then the drive gradually increases the voltage and frequency, causing the current to ramp up smoothly, as you can see in that table. The formula here calculates this peak current, which goes up to 1.5 of the full load current. After that, you will achieve the steady state, which happens about 5 to 10 seconds later. Once the motor reaches that target speed, the current will drop to the running current, as you can see here. Now, locked rotor current is slightly different. The table will calculate 9 seconds of locked rotor amp current. I think that was 66. Let's enter 66 and calculate that. That would also allow for the additional pump, which is about to start, and the generator needs to be sized up to be capable of supporting both pumps. One which is in a locked rotor state condition and the other in a startup. What else do we have? Obviously the distribution boards, they are just taking the load as it is. That's why it's set as standard. Smoke fans use DOL. Now let's choose something else. Soft start. Okay, smoke fan 1, you will see now I changed the smoke extract fan to soft start. The formula used for soft start reduced the voltage during startup, leading to gradual torque. Let me just show you a comparison. VSD next to the same load. You will see the difference. So extract fan 2 is VSD, extract fan 1 is soft start. That's the difference. With a soft start, the gradual increase in torque, and the start, the current is about 1 times FLA, then every second it increases, ramps up to about 2.5 FLA. This lasts about 5 seconds, and then in the comparison to VSD, the peak current is similar. It's about 1.2 times FLC, it's steady after 5 to 10 seconds. In this calculator, we assume 5 seconds. But the load is a bit steeper than with the soft start. In soft start, the load is more gradual. It starts at 1 times FLA and then gradually increases every second. The duration lasts anything between 5 to 10 seconds. The calculator assumes 5 seconds. Then it goes back to steady state. With VSD, the load is steeper, it rises higher and then stabilizes in about the same period of time. So if you want this calculator, feel free to use it. It's absolutely free. No need to enter any details, no email addresses. If you like it, please share it, comment, and let me know if you find it's useful or any improvements are needed. Thank you for watching.